Today I am going to start the second chapter, relations and functions. Here we have to understand many basic concepts by which we can understand not only the first PUC, even second PUC. The topic relation and functions, it is there in first PUC and also second PUC. The continued part you will see in second PUC. That is why I am telling it is very necessary you to understand very perfectly in first PUC, relations and functions. Then you will understand the terms and the problems what you see in a second year. Now coming to the point, I want to see that in this first year certain restricted syllabus that we see, under which we are going to consider one by one. First of all, we have to understand the sets, product of sets that we call Cartesian product we tell. Here the question arises that why we use the word Cartesian product. When you are taking A and B are two non-empty sets, as you know, A is one set, B is another set. A cross B, or you say A into B, that is called Cartesian product we tell. Don't think that A is also, B is also, both are set non-empty sets. Then their Cartesian product is written as A cross B. And here the question arises that why the term is used Cartesian product? Because this is related to the coordinate geometry, analytical geometry. Because here we see that the other part of the mathematics that is called coordinate geometry, means where the coordinates of the points in a plane or in a space we are discussing. So that is why Cartesian means coordinates. And here also, when you find the product of the two sets A and B, you will get the Cartesian coordinates we find. That is why we see that Cartesian product. When you are finding the Cartesian product, we will get a new set in which we say that ordered pairs. What you say? Ordered pairs we can say. Suppose if you say that let A is equal to one set 1, 2, B is equal to 5, 6. Then what is the Cartesian product? A into B is, what do you say? A is 1, 2 into 5, 6. When you multiply Cartesian product, you will see that 1 into 5, 1, 5, 1, 6, 1, 6, and 2, 5, 2, 6. See, after finding the product of two sets, we will see the elements are in the ordered pairs. These are called ordered pairs. 1, 5, 1, 6, 2, 5, 2, 6. What we call them? Ordered pairs we tell. When you get the ordered pairs, when two non-empty sets are multiplied according to the Cartesian method, Cartesian product, we'll see that ordered pairs. So now the question arises that ordered pairs means what? Here we find that 1 5 1 6 2 5 2 6, these are called ordered pairs, we tell. Then again ultimately the question arises that what do you mean by ordered pair? And here you see that always that definition of Cartesian product A cross B is equal to always see xy, and x belongs to A and y belongs to B. Means that first elements are belonging to the set A, second elements are belonging to set B. So A cross B is equal to xy if you get ordered pair, where x belongs to A, y belongs to B. This is the definition of Cartesian product. Suppose either A or B is a null set, and ultimately you can see that A into null set is again a null set only. Cartesian product of a non-empty set A and null set is again a null set only. So what is the definition of Cartesian product? You can see that this is the definition, xy such that x belongs to A, y belongs to B. Means that you see 1 1 2 2 belongs to here only, second elements 5 6 5 6 here only. The point is that first coordinates, first elements belong to the set A, second coordinates belong to the set B. So this is the definition of Cartesian product. Whereas when you see that Cartesian product in terms of ordered pairs, the question arises that what is ordered pair? So here I want to define that what is ordered pair. Ordered pair is defined as, once again I say that it is defined as a pair of objects, listed in a specific order. Once again, a pair of objects listed in a specific order, separating them by commas. You see, I am telling in general A, B. This is ordered pair. Ordered pair is defined as a pair of objects listed in a specific order, separating them by a comma, enclosed the pair in parentheses. Enclosed a pair in parentheses. Parenthesis means that is a bracket. In Kannada you can see that avarana. Once again I say what is ordered pair? Ordered pair is defined as a pair of objects listed in a specific order by separating them by a comma and enclosed the pair in a parenthesis. Enclosed in a parenthesis. So that is called ordered pair. If you ask that what is ordered pair? Ordered pair means the two objects written in together in a particular bracket. That also you can say. Two objects grouped together you can say. Ordered pair means what? Two objects grouped together within a parenthesis. That is also called ordered pair. Ordered pair means two objects grouped together in a parenthesis. But in more detail, if you want to understand, ordered pair is defined as a pair of objects listed in a specific order separating them by a comma and enclosing the pair in parenthesis. Parenthesis means what I already said, one kind of bracket. So this is the definition of ordered pair. What is the definition of Cartesian product? Once again I repeat, I already told in the examples. Let A and B are two non-empty sets. The Cartesian product is denoted by A cross B, in which you can see that xy such that x belongs to A and y belongs to B. So this is the definition of what? Cartesian product and ordered pair. So today I want to concentrate only on Cartesian product and how we see the variety of sums. I don't want to discuss about the relations. I want to discuss only the Cartesian product perfectly. The first exercise in the textbook will go through only the Cartesian product. So Cartesian product is nothing but what? A pair of objects listed in a specific order, separating them by a comma and enclosing the pair in parenthesis. Cartesian product of two non-empty sets is defined as A cross B is equal to xy such that x belongs to A and y belongs to B. So here, if you consider one set is, I want to take two sets. Look there, that one more example I am giving you. Here I want to tell that two colors I am taking here. What color? Two colors. One is red and one is blue. Set A contains two colors and set B contains three objects, B, C, S, I say. And here you understand that basically that BCS means object or element. Of course, for reference, B stands for bag, C stands for coat, S stands for shirt, you say. You have to tell the Cartesian product A cross B is how much? Understand? How many pairs we find after the Cartesian product? So what I say now, you have to make in pair for red, blue. So shall I write red R B, red blue. Next red C coat and red and shirt. See here? How many? Red, blue, red, C, red, yes. And next you will see that blue, blue, blue means blue bag. Next, this blue coat. Next, blue shirt. So these are the ordered pairs we find after the Cartesian product. 1, 2, 3, 4, 5, 6. Ordered pairs you got. This is the way of finding what? The Cartesian product. Particularly when you see that in a diagrammatic way, if you want to see that, the same. See this diagrammatic way, not necessary, but even I tell you, this I want to write blue and what you say red. This is red and this is blue. This is set A and here 1, 2, 3 B, C, yes. This is set B and this is set A. How you find? Red, blue, you see, red, blue red coat, red C, red shirt, red shirt. Next, again, you see, blue B, blue C, blue shirt. So this is also the way of representing the Cartesian product. And here I have shown with the diagram that how we find the Cartesian product. Look this is the set A, this is the set B, how we have got it. So I hope that how to obtain the Cartesian products. Suppose if you say, instead of taking A, B, if you take then two non-empty sets, P, Q, if you say, P and Q are two non-empty sets, and PQ is equal to PQ such that P belongs to P and Q belongs to Q. Yes, this is a Cartesian product. P and Q are two non-empty sets. After the multiplication, Cartesian product, we will find PQ, where P belongs to P and Q belongs to Q, and this is called the Cartesian product, you can say. And basically, when you see that either one of them is a null set, the Cartesian product is also null set. So I hope two terms particularly we have discussed. One is ordered pair and other one is Cartesian product. Suppose if you say that values, for example, if I say A is equal to one set, A1, A2, see, A1, A2, and another set I am taking, B is equal to. Here you have to tell that many letters accordingly you have to go for B1, B2, B3, B4. So here you find the Cartesian product. How do you see that? Cartesian product. The diagram already told you, A is down, A1, A2, and these are B1, B2, B3, and you see that B4. So now you see the product A1, B1, look this, A1, B1, A1, B1, next A1, B2, A1, B2, A1, B3, A1, B4, and continuation, next to over, next A2, B1, you see, A2, B1, A2, B2, A2, B3, and A2, B4. So this is the Cartesian product. I hope you have understood how we find the Cartesian product in this case. Now, in all the way, when you find that Cartesian product, how we are multiplying with that diagram. Now, I want to see some points which are to be remembered, and after that we will go for continuously the problems. So, which are the points to be remembered that you have to understand here? Basically, you can see that when you write an ordered pair, and you have to see, suppose one ordered pair is there, A1, B2, if you say A1, B2, and this is not same as B2, A1, and this is different and this is different. A1, B2 is different, B2, A1 is different. These are the ordered pairs are used to represent the points in the plane. The ordered pairs are used to represent the points in the plane. And here you can say that ordered pairs A1, B2 is not equal to A2, B1. And why? Because their positions in the plane are totally different, and that is why we take it in that fashion. Suppose if you say, this is one point. Second point I am discussing. Suppose A and B are two non-empty set, and here the number of elements in A is P, you say, and number of elements in B, you say Q. What is the number of elements in Cartesian product is nothing but PQ. You understood that? The number of elements, for example, PQ, and number of elements in A cross B is P and Q. This also we have to understand, we have to follow in future things. So here we have to understand that how we write this, and accordingly we can see the results. And out of two sets A and B, if one is infinite, and so that A cross B is also infinite. What I mean to say, they are non-empty, of course they are not finite. Out of two are finite, we have some particular explanation. Out of two, one set is infinite, then A cross B is also infinite, and accordingly we can continue the results here. So if you see that if the two ordered pairs are equal, AB is equal to XY, if you say two ordered pairs are equal, only that the corresponding elements are equal. What I mean, if you say AB is equal to XY, there must be, if, then what? A equal to X and B equal to Y. And conversely means if A equal to X and B equal to Y, then ordered pair AB and XY are equal, if and only if that condition may be used. That is why I say that if you go for studying that ordered pairs, when they are equal, their first elements are equal and their second elements are also equal. This is also important point is to be followed. Once again, two ordered pairs are equal if and only if what? Their first and second elements are respectively equal. Then only we say that the two ordered pairs are equal. Now you can see that one more point very important, that is the last point that we can say, and accordingly we can see that up to, because so far only you have seen that ordered pair, Suppose A into A, this is also Cartesian product, and you say that A equal to 1, 2. How to find out the Cartesian product? 1, 2, see this into 1, 2. So how to find out the Cartesian product? Ordered pair, you see that 1, 1, yes, 1, 1, 1, 2, next 2, 1, and next 2, 2. This is the way of finding the what? Cartesian product. If A into A, if only one non-empty set is considered, there also you can find out the A cross A, Cartesian product of A and A. In case, suppose that three sets, if I say A into A into A, already I told you A into A, if you take that, you see that XY such that XY belongs to A, because X belongs to A, Y also belongs to A. So this is the definition. In case if A cross B, we used to tell X belongs to A, Y belongs to B. Suppose A cross A means both X and Y are belonging to the set A. Now, similarly, the extension A into A, then what is the definition? So you have to find out X, Y, Z such that. So here only one set is there. That is why we write that X, Y, Z belongs to AS. But the thing is that this is not an ordered pair. This is, that is different. Ordered pair means two elements we can say. And here ordered triplet we are using. What do you say? Triplet. What do you say? Triplet. And here you can see ordered pair you can say. And here ordered, what you say? Ordered triplet you can say. If two are there, ordered pair. If three are there, ordered triplet. So this is only the introduction part in first PUC, ordered triplet. Even it is not there in second PUC, that will be continued in a graduation. Okay, no problem. Cartesian product of A into A, I have told you. Cartesian product of A into A into A. And here one difference I want to tell for both. These ordered pairs are used to represent the points in the plane. Once again, ordered pairs are used to represent the points in the plane, whereas ordered triplets are used to represent the points not in the plane, in the space. So, difference is the points in the plane, here point in the space. So, ordered triplets are used to represent the points in the space, and ordered pairs are used to represent the points in the plane. Plane means it is a blackboard. Space means is this three-dimensional. Space, once again I explain, this is the two-dimensional, this is the three-dimensional. Three axes, x, y, z axes, which are mutually perpendicular. So that will be studied in vectors. So here I have explained some important points in this regard. Now I want to see the variety of problem based on the things which I have explained so far. Ordered pair, ordered triplet. Now I want to go for one by one the problems, and that you can understand. So problems that I say, and you have to understand very carefully. First I write, if x plus 1 y minus 2 is equal to 3, 1, find the values of x and y. See, find the values of x and y. So here you have to understand that basically we have to understand what we have to understand here, that given what two ordered pairs are equal. What is that point I have told you in the theory? The two ordered pairs are equal, then their corresponding elements are equal. I mean to say first elements are equal and second elements are equal. Look this, what I say. When two ordered pairs are equal, you may write, since two ordered pairs are equal, then corresponding elements are also equal. See, this is the definition of two ordered pairs are equal. Once again I repeat that the two ordered pairs are equal, the corresponding elements are also equal. So using this idea, now I want to tell, now what x, now what given, what is given? X plus 1 y minus 2 is equal to 3, 1 given. What I mean to say, these two ordered pairs are equal. Then what is the definition say? In the examination you are not supposed to write the definition of two ordered pairs equal definition. So the corresponding elements are equal, means first element of this ordered pair is equal to first element of this ordered pair, second element of this ordered pair, second element of this ordered pair are equal. Corresponding elements means that this means to say x plus 1 equal to 3 and y minus 2 is equal to 1 and x is equal to 3 minus 1 and y equal to 2 plus 1. X is equal to 2 and y is equal to how much? 3. So the question is finding the values of x and y. And what are the values of x and y here? You have got x is equal to 2 and y equal to 3. Then what we have used here? Two ordered pairs are equal. And so we have find the elements, means x, y, z here. So now coming to the second problem. You have to understand the theory what we have used. When you say that two ordered pairs are equal, if their corresponding elements are equal. Corresponding elements are equal means what? First element of first ordered pair is equal to first element of the second ordered pair. Second element of the first ordered pair is equal to second element of the second ordered pair are equal. That is the definition. Okay, now see the second problem. What is the second problem? You see, if P is equal to A, B, C and Q is equal to only R. From the set, here you have to see, form the set, not from. What do you say? Form, construct. Form the set P cross Q. Question you see, form the set P cross Q. Not only that, Q cross P. Q cross P. Question not completed. Are these, see the question, are these two products equal? Here you have to see the question. First you see form P cross Q and Q cross P, then you say whether they are equal or not. Solution. First I want to find out the P cross Q. That is, P means what? A, B, C. Q means what? R. Better you write in this fashion, so it is easy, no confusion. Yes, how to find out this? A into R, A comma R, A comma R is over, next B comma R, next C comma R. So this is the product. What is this? P cross Q. Whereas now I want to find out Q cross P. Q means what? R into P means A, B, C. Now Q cross P is equal to R A, yes, R B, next R C. So here you understand both are equal or not. P cross Q is like this. Q cross P is like this. Both are not equal. Once I told you, A1 B1 is not equal to B1 A1. So here that AR not is equal to RA. That is why these two products are not equal. Once again I understand here, A1 B1 is not equal to B1 A1. When they are equal, suppose A1 equal to B1, B1 equal to A1, then you can say both are equal. So you have to tell that. Basically I write that here once again, A1 B1 is equal to A2 B2. And here this is equal, then only you can tell. But here the question is A1 B1 here is equal to B1 A1, and it is not possible. This is the pair representing one point. This is the pair representing the another point, and these are not equal. So try to understand A1 B1 is not equal to B1 A1. And here you say that here AR is there, RA is there, BR is there, RB is there, CR is there, RC. So both are not equal. So try to understand in general, if you coming to the point, in general P cross Q is not equal to Q cross P. Why? Why? Because A1 B1 is not equal to B1 A1. So that means to say XY is not equal to YX. So these are the two different ordered pairs representing the two different points in a plane. That is why they are not same. Now you can understand what we have done in this case. So because the definition of equality of ordered pairs, and here you have to see AR is not equal to what? The pair CA, and we conclude that P cross Q is not equal to Q cross P. So once again I say that AR is not equal to RA according to the equality of ordered pairs, because A is different and here A is different, R is different. So that you cannot say that both are equal. So what do you understand here? The product, are these two products equal? No, both are different. So this is a solution you can find out by using the Cartesian product. I hope you understood that. Definition here we have used. What definition? Equality of ordered pairs. When the two ordered pairs are equal, their corresponding elements are equal, or otherwise they are not equal. Now I am going to see the third problem. What is the remedy here? You see, let A is equal to 1, 2, 3, B is equal to 3, 4, and C is equal to 4, 5, 6. Question is 4 problems. Find first problem, A cross B union C, and second one is A cross B intersection A cross C. Third problem, what? A into B union C. Fourth one, A cross B union A cross C. So here, how to find out all 4 problems? I am explaining one by one. How to find out this? First I have to see this. A cross Cartesian product of A and B intersection C. First, now you have to find out B intersection C. You have to find out what is B. 3, 4. What is C? 4, 5, 6. Is there any common intersection? Is what? Is there any common? Only 4 is common. So what I say now here? The question is that basically, but here you see that question is A cross, therefore A cross B union B intersection C is equal to A is how much? 1, 2, 3, 1, 2, 3, and into intersection B intersection C is nothing but how much? 4. So their product you can find out. How you say? 1, 4, you see 1, 4, 2, 4, 3, 4. Yes, this is the answer for the first question, that is called A cross B intersection C. So this is over. Now we have to see that instead of going for the second, I want to see this third. I hope you understood that how we have got at this. Now I am going to see the third. I want to take simultaneously second and fourth. So I hope you understood the first one, how we have done. Now I go for finding the third one. So what is third? See, in third, what we do, B union C we have to find out. First, B union C. What is B? 3, 4. Union. What is C? 4, 5, 6. So B union C is equal to 3, 4, 5, 6. Union means all the elements without repetition. And here you have to see that B union C. Therefore, A intersection B union C is equal to A. A is what? 1, 2, 3 into what is B union C? 3, 4, 5, 6. So what is this product you have to tell? So it is very lengthy process that you can do it here, and accordingly you can see the answer here. So anyhow, I have to explain how to find out this product. See that Cartesian product. First one, 1, 3. See 1, 3, 1, 4, 1, 5, 1, 6. Next 2, 2, 3, 2, 4. 2, 5, next 2, 6, next you see that 3, 3, 3, 4, 3, 5 and 3, 6. So this is a Cartesian product. A cross B union C. This is the way how we find all these things. Now we want to see the results third and fourth. I hope you understood that how you have got A cross B union C. This is the way. Now I am going to explain that A cross third, second. These two are over now. Now you see that how we find this, and accordingly you can see the results. So when you go for writing the results here, and we have to write the result correctly here. Now I want to see that second one, because A cross B and A cross C. First I have to find out which one I am telling now. Number second. What is A cross B? First we find. Now A cross B. A is what? 1, 2, 3. Cross B is how much? 3, 4. See, A cross B is equal to 1, 3, 1, 4, 2, 3, 2, 4. Here next 3, 3 and 3, 4. This is A cross B. And next you have to see that A cross C. A cross C. Now A cross C is equal to A is 1, 2, 3 into C is 4, 5, 6. See the answers here. You have to write 1, 4, 1, 5, 1, 6 and next 2, 4, 2, 5, 2, 6. Next you have to see that 3, 4 and 3, 5 and 3, 6. So here you have to see that how you have got all these results. A cross B, A cross C. Here you have got A cross B, here you have got A cross C. Now the question is, the first answer is here. Therefore, question is A cross B, bracket complete, union A cross C. Is there a common element you have to write in both? A cross B. Is there any 1, 3? Is there 1, 3 anywhere? Nowhere. 1, 4? Yes, 1, 4 is there. One ordered pair is 1, 4. Next, you have to see that 2, 3 here. 2, 3 is here. 2, 3. No. 2, 4 is here. Yes. 2, 4 is there. So here 2, 4. Next, 3, 3 is anywhere here? No. 3, 4. Yes. 3, 4 is also there. So, how many elements you got in common, that you have to understand here. That is, accordingly you can proceed. So, 1, 4, 2, 4 and 3, 4. This is this part. Now coming to the last, fourth one, if you see. Fourth one, you have to write that union. A cross B, instead of intersection you write union. What I say here, A cross B, A cross C. Then you have to write all the elements without repetition you write. Which are the repetitions now here? 1, 4 and 2, 4 and 3, 4. You have to write 1, which are the right mark? You have to write 1, 2, 3, 4, 5, 6. And here 1, 4 you have to drop, 1, 5 and yes, 2, 4 don't take because already you have taken. 1, 4 already you have taken, and 2, 5, 2, 6 this also you have taken. This, which I have written the right marks, you have to take under the union. Means that in the union you have to write only the elements of A cross B, elements of A cross C without repetition. Union means all elements of this and all elements of this, either this or this. That you can write that without repetition. So which are the elements you have to write here? Already I have written this, that which I have written repeated we have to take only once. So this is the case with this problem. Now I go for the next problem, how to solve it this. And here you have to go for understanding that union and intersection, that already you have studied in the first chapter, set theory, sets. Now problem number 4, you see what it is exactly. Problem number 4. Look at this first very carefully, you observe this and accordingly you can write. See, question is, if P is equal to 1, 2 and here you have to see that question is, form the set what? P, you have to write it. So here you have to understand that how to form this set. This 3, that triplet I told. So accordingly you can understand how to find out the triplet in this regard. So basically I have told you that ordered pair is in a plane, ordered triplet in a space. So how to find out the triplet I am telling you. Look this first. If A equal to 1, 2, form the set P cross P cross P, Cartesian product, extension. First what I do it, I want to take P cross P only, you have to find out. What is P? 1, 2 into 1, 2. So what is this answer, you tell me first? Ordered pair 1, 1. Look this, 1, 2. Next 2, 1, 2, 2. Yes, this is ordered pairs. Now here you have to write A, no, P into P into P is nothing but P into P into P. So what is P into P? Here you see P into P is 1 1 1 2 2 1 2 2 into P is 1 2 1 2. So now you have to find out that how to multiply this. Looks easy going for you. That 1 1 you take it here 1. Next 1 1 2. Look this 1 1 1 1 1 2 I have taken. Next 1 1 is over. Next this 1 2 1 1 2 1. Next 1 2 1 2 2 is over. Next look this 2 1 1 2 1 2. Next this 2 2 1. Next 2 2 2. See 1 2 3 4 5 6 7 8. See how you have got this ordered triplet. I have told you how you have written this. How you have got first A cross A, then A. So this is the way how you have got the ordered triplet, and accordingly you can see the answer here. Now we have to see that 8 elements you have got in ordered triplet, but in the textbook you can see the direct answer, but I have written one step more for the clarity purpose. This is a way of finding triplet P cross P cross P. Now I want to see the problem number 5. I hope you have understood how you have got this P cross P. Okay, so this can be followed. Now what I say that problem number 5 you say, in which what we have to find out. Very simple the way I am telling you, and the formula for that you see which we have already discussed. What is the problem number 5 you say? If R is the set of all real numbers. See the question, set of all real numbers. What do the Cartesian product? What do the Cartesian product? Cartesian product R cross R. R cross R and R cross R represent. See the question here. Question is R is a set of real numbers. What do the Cartesian product R cross R? What do the Cartesian product R cross R? So here you have to write the answer that the Cartesian product R cross R representing the point in a plane. Cartesian product R cross R is the point representing in the space. That's only the difference. Once again, what do the Cartesian product R cross R? R cross R. This represents the point in the plane and this represents the point in the space. Yes, this is only the answer. So you can write that R cross R represents, simple way, represents the point in the plane. Try to understand, right? In the plane, try to understand. And R cross R represents the point in the space. Try to understand. This is the difference. Ordered pair point in the plane ordered triplet, this is ordered pair, and this is ordered triplet. So this both represent the plane, represent the point only, but this point in the plane, this point in the space, that is the difference between ordered pair and ordered triplet. Yes, the last problem I am discussing now, and accordingly you can see the exercise number 2.1 in the textbooks. See the last problem, and that you can do it. Sixth, you see, if A cross B is equal to PQ, PR, MQ, MR, find A and B. See the question. Find A and B. It's very simple way I am telling you. A is equal to what? See, you see the ordered pairs. Ordered pairs. The first elements are in A. Second element are in B. That's the difference. But here you can see all the, what do you say, distinct first elements only you have to take. Means P already is there. M, yes, only two. What do you say? A is a set of all distinct first elements, not repeated. A is a set of all distinct first elements, and B is the set of all distinct second elements. Second element means what? Q, R, only this one? Yes. Find A and B means one may be right. A is the set of all first distinct elements, B is the set of all second distinct elements, PM and QR. And one more, I want to see the last this problem, and that completes this part of the discussion. What is this? I think here this is the last problem, and no chance of studying. But now you see that the problems on this which I have discussed so far, is today only you see the textbook second chapter 2.1, all problems you have to work out. Meanwhile, I am sending you the answers for those questions. In the next class, possibly I want to see that second part, that is relation, and third part, that is our functions. I hope you have understood all these problems. Similarly, you can work out the problems which you can see in the exercise 2.1. Thank you.